Okay. All right, we have 3 more problems and we're going to get them done. So here we go. A parallelogram has sides 18 and 26. Both of these last 2 problems have required you to remember a little bit about the geometry that you learned. So you need to remember that that's a parallelogram. There's an angle of 39 degrees. And your job is to find the shorter diagonal. Now, kids, use your logic. There's this diagonal, and there's this diagonal. Now, just doing that, I can tell you which one's shorter. This is the shorter diagonal. Would you agree with me?
Yes.
You have to be able to figure that out on your own. That's the shorter diagonal. Now, I know this side down here is also 26. So drawing in that diagonal, I have created a triangle, and my job is to find the length of that segment. Now, I know when you see this, you might be thinking 1/2 side sine, but what does that do for me?
Area.
That gives me area. So if I wanted the area of this thing, that is what I would do. I want a length. Lengths are found, law sines, law cosines. So look at that scenario, which one should I use? It's gotta be cosines. Do you have a pair, guys? Nope. So it's gonna be cosines. So the angle is 39. The side's x, gonna be squared, always in law cosines. And what's x squared gonna equal? 18 squared plus 26 squared minus 2 times 18 times 26. Since the variable's over here out of the way, you can just type it in. Now, when you type all that in, you get something big like 272. But remember, that is x squared. So I'm going to raise that to the 1/2 power. So just raise it to 0.5. And x equals 16.51. Need a unit, feet. Not feet squared, because feet squared would be area. All right, now we've got a situation. We know this is 860, this is 78, this is 175. All right, so we got all this stuff. Find distance AB. Find distance AB. Anytime it's a distance, it's going to be law sines or cosines.
Yeah.
So which is it?
It's cosine.
It's cosines. So here we go. Out here will be cosine 78. Here will be x squared. What will be in the middle here?
860 squared plus 78 squared.
No.
Or no, 175 squared. Minus 2 plus 2.
Don't forget to square root it, otherwise you're going to get a huge number. You got to square root it. And that's feet also. 841.22 feet, is that what you got?
Yep.
One more. Uh-oh, no picture. I am on my own.
I love it. Love it.
All right, 2 airplanes flying together in formation take off in different directions. So I'm gonna go ahead and set up my coordinate axis system. Here is where the planes are taking off from. One flies due east at a speed of 350 miles an hour. The other flies east-northeast. Now remember, this is east, this is north. So this would be northeast,
Yeah, but it's in between.
and then east-northeast is this guy right here. And how big is this angle right here? 22.5. Because northeast is 45, and that's half of that. So here's one plane, and here's one plane. Okay? I'm gonna take this out so it's not confusing. Alright? Now, what do I know about these planes? They are gonna fly for 2 hours. So the first plane going due east is gonna go how far in 2 hours? 700 miles. The other one is gonna go how far in 2 hours? How far? 760? 2 hours at 380 miles an hour? How far apart are the two planes after that 2 hours?
How far apart?
How far apart are they? Does that make sense to you?
Yeah.
How far apart are they? Okay.
Cosine again.
There'll be law cosines again. Your angle is gonna be 22.5. X squared. 760, 700. Remember, the square root, you can either square root or you can just raise it to the 0.5 power. I got it at being 290.85 miles apart.
There we go.
All right. Now, get out that paper I gave you at the beginning of the period. How many triangle, oh, right, I mean do that. So, 5, 6, we just finished that, so that homework will be due on Wednesday? No, Tuesday. That homework's due Tuesday.
5-5's Monday.
Yeah. I'll post a request date after I sit there with the schedule and figure it out. I'd like you in the packet that I gave you to turn to the very last page. The very last page says extra practice, 5-5, 5-6. The front of the very last page. And in the middle of the page is a weird shape. And your job is to find the area of this shape. Now, there aren't any formulas for shapes like this. This is just some random quadrilateral. It's not a rectangle or anything like that. So do you have a thought about this, Robbie?
Would you split it between the two closest diagonals and then find both areas?
Okay, so Robbie says, I'm gonna do what we've been doing this morning, and that is when we have a shape, let's split it into triangles. Now, I split it this way. I think that's the way he wanted me to do it. I could have split it this way. I'll give you a little hint. If you have a right triangle, I try not to split that one. So I'm gonna go with this diagonal. Two things though about that. This is a right triangle, so everything you know about SOHCAHTOA, Pythagorean theorem, all that works in this triangle. I'll call that triangle 1. None of it works in triangle 2. Also, when I drew that diagonal in, it did not cut this angle in half. So please don't make the assumption that this is like 52 and a half. It isn't. It isn't. So don't do that. Can we find, I mean, the area of the whole thing is going to be 1 plus 2. Can we find the area of number 1?
Yeah.
We have a side and an angle in between. So the area of that triangle will be 1/2, 18, 24, sine 90. Would everyone agree with that? Which is that G16?
Yeah.
All right, square feet. Okay, so number 1 is done. That's easy.
You have just done 1/2 base times height.
Totally you could. The sine of 90 is 1. So yes, 1/2 base times height. Absolutely. Base and height right there. You sure can. All right, triangle 2. Now this is going to be a little harder because the only thing I know about triangle 2 is one side is 28. Can I find another side of triangle 2? How? I could do law cosines. I could also just do the Pythagorean theorem, right? Because that's a right triangle. Now, either one is fine. It's like what Nyla was saying. It doesn't matter. This is a right triangle. So I'm just going to do the Pythagorean theorem with 18 squared, 18 squared, and 24 squared, and square rooting that, and I got 30. Did you get 30? So now I have 2 sides of my triangle. All right? What do I need? What else do I need? I don't need any angle. I would love to have this angle. Wouldn't that be the best angle to have? Problem is, I can't find that angle.
I think you can.
How can I find that angle?
And then subtract it from 1/2.
Oh, I can find this angle. That's the one I want to find right there, and then subtract it from 105, and that'll give me the one I want. So we got many options. I heard Braden say SOHCAHTOA. So for example, I can look at this angle and say tan x equals opposite over adjacent. Okay, that's one option. What's another option if I want, I know that's 90, could I do law signs?
Yeah.
Sine 90 over 30 equals sine x over 24? You absolutely could. You actually could do the law cosines because you know all 3 sides. So you got lots of options. Let's find angle x however you want to do it. I got 53.13. Tell me if that's what you got the way you did it.
Yeah.
Okay. So now I gotta subtract that from 105. 51.87. Can I find the area of my second triangle now? 1/2, 30 times 28 times sine 51.87. I got 330.38. Anybody else get that? So what's the answer to the whole question then?
546.38.
rest of the problems on the page here? There's 4 more. Let's do a couple more of these. What do you wanna do? Number one? Number one is a pentagon inscribed in a circle of radius 5. Alright, so we already did one kind of like this, only it wasn't a pentagon. So 1, 2, 3, 4, 5. Connect the dots. There's my pentagon. And the radius of the circle is 5. So remember doing this before lunch? Yes? I would like to find the area of this triangle right here. But in order to do that, I need this angle. What is it? 360 divided by 5, which is 72. So my area of my triangle is 1/2, 5, 5, sine 72. And I'm not gonna write that down because I really don't care about that. I'm just gonna hit times 5. And the area of your pentagon is 59.44 units squared, whatever the unit is. One more, and then I'll shut up. Pick another one. 2? Gotta know, in order to do number 2, we gotta know what an isosceles trapezoid is. So isosceles trapezoid. That's one of these guys, right? And the sides of the trapezoid are 5, 5, 10, and 12. I can certainly split it diagonally. Do you see why I'm a little bit perplexed? I don't think I have enough information to split it that way. Abe, did you have an idea?
Square, 2 triangles.
Oh, well, I called on Abe, but Peter, of course, blurted it out. Which is fine. We're all family. There we go. Split it this way. Is that what you were going to say, Abe?
Yeah.
Yep.
Sucks.
Now, when I do that, remember this whole bottom is 12. But when I do this piece up, this much of it's 10. That makes these two what? Now remember, it is isosceles, so everything is even. So 1 and 1. Now, can I find, well, first of all, does anybody happen to remember the formula for the area of the whole trapezoid? If I decide to do the whole thing, no one remembers. Okay, then you're gonna have to do it by pieces. So what's the area, oh shoot, what do I need to figure out before I can do anything? I gotta figure out these, right? Okay, this is a right triangle. So 1 squared plus, I'll call that h squared, equals 5 squared. So this will be the square root of 24, or 2 root 6. The area of the triangle is 1/2 base times height. This is the base, this is the height. The area of the rectangle is 10 times 2 root 6. And that triangle is the same as this triangle. So I got that one twice, and this one once, all added up, and that will be the answer to the question. So I think your answer is going to be 21 root 6.